Today we'll continue where we have stopped previously about GIS. We talked about different softwares, we talked about different open softwares and how GIS has been evolved and what were the different types of maps, and now what are we going on in this current generation. So for that we should understand what is data type, what type of data type goes inside. Is it spatial and non-spatial? Within spatial and non-spatial, we are having different types of measurement scales, and how do we use them into our database. So with this a short introduction, we can go ahead with the further topics. This is an informatory session, so people who are practicing GIS and who want to know about geoinformatics, I think this video would help you to understand what exactly we are dealing in. So let's go into a brief introductions of all this thing. So GIS is one of the most important tool currently in this generation because it is fueling the spatial analysis and also giving vivid analysis and visualization. So it's just like data is a lifeline for GIS, and the most important fundamental data types is very much important for anyone to look on to understand the powers of GIS. So GIS data is broadly classified into primary two types, that is vector and raster. Each represents a geometrical information in a very distinct manner, which offers unique advantages for different applications. Now, beyond this, there are several newer complex data forms which we can just brief out till the end. So, as I said, there are few pillars of this GIS. So, on that are vector and raster dataset. So, spatial takes you to a place where you have to know where does this data come from. If you are having a data, what does the data mean? So what is the data's information, like the location, the shape, the geographical feature, where is it? This is the visual component that you're going to see on the map. So there are two types of this spatial data, as we said. One is vector, another one is the raster data. So this vector data uses points, lines and polygons to represent a discrete object with a clear boundaries over a map. Now point can refer to a single locations where you are having, for example, you can pinpoint a location on the map. For it can be a street lamp, or it can be a fire hydrant pole, a hospital, a single tree, based on your requirement of the data. Next comes lines. Lines represent the linear features. This can be road, this can be rail lines, it can be rivers, utility lines, and so many other things. Next comes polygons. These represent the defined boundaries. Now you can think of a lake, a geographical park, you can have different buildings. Usually buildings look at as square. Okay, so country border, watershed maps, all these are a polygon. These represent a defined area. Next comes raster. Raster is a type of data set that deals with grids of cells into different pixels, and it represents a continuous phenomenon. So these pixels have one characteristics for a particular location. For example, if you look into a satellite image or aerial photograph or digital elevation, so these are all the examples for raster data. Now weather map shows temperature variations across the area is another one of the best example. Next comes our non-spatial data. That means what? We understood where, now we have to understood what. So what does this data give us? So non-spatial data gives us the attribute or a descriptive information of a particular feature which is linked to a spatial data. Now this answers the question, what is it? What character is it? For example, it can be stored into a feature in a table, or it can be having certain values, ID, frequency, and so many other things. So with this mindset, let us dwell into each of this dataset. So for example, if you have a point you are representing in a hospital, that point behaves as a spatial data. Now, what would be a non-spatial data? The description of that. The description of that data is, for example, name of the hospital would be general hospital, number of beds 500, types of hospital that can be public or any kind of things. So whether it has an emergency room, so all these informations can be associated with a non-spatial information. So once when you click onto the map and you analyze, you can view all the spatial information in your attribute table in any of the software. So the power of GIS lies in the ability to link these two types of data and allowing a complex analysis to visualize. For instance, you can ask GIS to show hospitals with spatial query with more than 300. So that means it is a combination of two data sets, that is complex analysis. Okay. Now let us understand what do we understand by the word vector data. So I say that it represents the worlds of discrete objects. What does it mean? It is a data that represents a geographical feature which has a distinct boundaries. Now think it is creating a digital map with distinct points, lines and enclosed area. To define it, a vector data uses a geometry primitives just like your points, lines which are called as polylines, and then polygons. These represent together a geographical feature on your map. So each of this feature is an object which is defined as a location and a shape. These are associated with the vector features in order to attribute the data. So which is typically stored in a table and describes its characteristics or a feature. Now for example, for points you can say a single coordinate which is having x and y represents a specific location. It can be locations of towers, it can be crime instance or particular measuring station areas or monitoring stations, so on. Next comes polylines. These are series of connected points that represent a linear feature. We use polyline command in ArcMap, GIS and other kind of thing. So for example, you can see road lines, pipelines, rivers, administrative boundaries all come into this feature. Next comes the polygons, which are a closed series of connected lines that represent an area. For example, boundaries of lake, boundaries of watershed, administrative buildings, okay, boundaries, district administration boundaries, all these things. Probably you will be saving all these things into shapefiles. There are some standard formats in this vector, which are shapefile, GeoJSON, then keyhole markup language, and geography markup language. Let us understand what do we mean by this. So shapefile is a type of a file which is used this was formed by ESR as a standard factor developed. It is a collection of the all files which stores your geometry, attribute, indexing formats. It has SHX, SHB, and usually it has been shaped by .shp file. Okay, next GeoJSON, that is how this is a format where we are using a Java inscripted object notation. So this is nothing but it is very popular for the web-based mapping. So vector data can be also saved in this formats. Next is keyhole markup language, that is KML or KMZ. So these are XML based type of formats which are primarily used for Google Earth or other virtual globes, where we can use this vector data and upload it into a Google Earth Explorer or anything, so we can see those features based on lat and long on that particular location in a better ways. Usually when we do some validation studies, like we cannot physically go to the particular place, but at that time we use this coordinates or points or features, and we try to upload it into Google Earth Explorer, so we can say that whether it is accurate enough or not. So those things work onto this. Next comes geography markup language, that is GML type of file. These are open geospatial type of things, that is OGC, for expressing the geographical features. So let us understand what does this shapefile and all mean. So shapefile is a digital vector which is storing the format of geographical information. This stores location, shape, attributes of different geographical features. Now they made ESRI developed this and made it as a industry standard format. So when we are able to share these products for analyzing, so we can do it. The uses of this are It can be used in mapping, spatial analysis, data sharing. So it gives visualization by creating maps for displaying the generic features like roads, rivers, lakes, and so on. Then planning and management, city planners can use shapefiles to analyze land use patterns. So these uses are vivid. I'm just briefing it down to these 2 points. Next is geospatial analysis. So they can combine the location data attribute to gain the insights such as evaluating and storing performance. And the other thing is data exchange. So we can able to transfer the data based on different software programs like cloud platforms and so on. But they have some limitations. What are those limitations? First of all, it has a file size limit. Sometimes when we are working out with some analysis, the analysis itself takes place for more than 5 to 6 GB. Sometimes if you're doing an excessive SWAT modeling, so at that time this shapefile limit goes to exceed more than 4 to 5 GB. So at that time you cannot share the whole form analysis in terms of shapefile and send it to your consultant or any kind of thing. So at that time file size is one of the constraint. Next is topology. So this format does not have a topological relationship between features such as in polygon and whatever you are going to do with that. Next, it has a single geometry type. For example, it contains only one feature, like you can only save polygon, you can save lines, you can save points. Sometimes we need to find a district boundary map, then you need to locate certain places. You cannot completely save this the whole features as a single shapefile. So it has this one constraint. Next is attribute table issues. So you can have a DBF format has a maximum field characters of 10 characters only. So it supports poorly for Unicode characters, and it has a very limited data types. So poor handling of null values and does not support advanced modeling or network type of data. Okay, this is about our shapefile. Another thing is GeoJSON, or we can say this is a text formatted which is easy for both of human and machines to learn. Usually if you are incorporating in Python or anything, so at that time you require certain scripts. So this type of format helps the machine to know these features. For example, you can use feature collection which contains arrays of features which gives geometry as well property. So what is geometry? This describes the shape and the location of a geographical feature using the word geodetic system, that is 1984 WGS coordinate reference system, which is common geometry types for point, line string, polygon, and multi-part geometries. So this contains non-spatial attributes and has metadata associated with features. They are all stored in JSON object for a key value pairs, which is included for detailed naming, descriptions, and relevant features. So they can be associated for various forms. So they are widely used for sharing, visualizing geospatial data on web maps with mapping tools. Next is about our keyhole markup language. This is also a XML based file format for displaying the geographical data in applications like Google Earth and other kind of stuff. So here it is used, we can pinpoint a location and add placements, we can create pathways, routes, we can add image analysis and store and share 3D models. This KML file has informations based on points, lines, and polygons, along with style and information like colors. Now this KMZ file is compressed into various versions. It can be in KML file, it has bundling with other associated files which are zipped together for easier sharing. So this originated from Google's acquisition for a company called as Keyhole. So the developer of the Earth Viewer program, eventually later it became as a Google Earth, they started using up this thing, and now it has been very much useful and adapted. The standard formats of vector are, other than that, is geography markup language, that is GML. What does it do? It is having an encoding and enhancing or exchanging the geographical data by creating an open geospatial consortium. So this represents the whole world geographical features like road, buildings, political boundaries, and they can be included both by spatial as well as non-spatial. So this gives us an opportunity for analysts and people who are designers. It serves as a complete modeling language for geographical systems and open interchangeable formats, which helps proper transactions on internet and cloud database. So this is about vector data set.